So dear student, today we will see the practical of measurement of vertical angle by using the theodolite. So we will see the title. So as it is written there, so measurement of vertical angle by using the theodolite. Now we will have with us 20-second theodolite. So we will use the theodolite of 20-second. Then aim of this practical is to measure the vertical angle between any two points by using the method of repetition. So now in this figure you can see that suppose these are 2 points A and B which are located on some elevation. Then we have to measure the angle between this point A and B from this station point O. Suppose that angle is the theta 1. Then we have to use the method of repetition. So in repetition method what happens? So we will repeat the measurement of angle in clockwise direction. So in this one we have to measure the angle in clockwise direction with face left condition of the theodolite and with face right condition of the theodolite. So once you have started from this point, then angle theta is measured between these 2 points. Then again we are taking the readings, that is theta 2. Again we are rotating the readings and we are taking the observation, that is theta 3. So this is the method of repetition which is used for measurement of vertical angle. We have to complete this process with the face right condition and with the face left condition, and we have to work in the clockwise direction, and at the end you have to observe the readings by taking the summation of the readings which you have observed. So now we will see the detailed components parts of this theodolite. So I have this theodolite with me. The least count of this theodolite is 20 seconds. So we will see the parts of this theodolite from bottom. Now at the bottom you can see 3 foot screws are provided for this theodolite. So these 3 foot screws are fixed to this base plate, and this portion of this foot screw and base plate is known as the leveling head. So use of these foot screws is for leveling of the instrument. So you can have the movement of these foot screws in the clockwise direction or in the anti-clockwise direction depending upon the setting of your grounds. So first you have to place your telescope parallel to these 2 foot screws. Then you can rotate your foot screws in inner side or in the outer side. Then you have to place this telescope perpendicular to that 2 foot screws, and then you can rotate the remaining foot screws in clockwise direction or in anti-clockwise direction. Then above this base plate we are having the level tube for observing the level of our instrument. So while doing the leveling you have to check that this bubble must be in the center before starting your practical. So this is one level tube and this one is another level tube. One level tube is fixed with the vertical circle. So this is vertical circle, this one is, and one level tube is fixed with the horizontal circle. So you have to take care of this both bubble tubes and make sure that these both bubbles are present in the center of your instrument. After leveling of this instrument, you have to mark your center point on the ground. So marking of your center point can be seen by using this center point knob. So by observing the reading from this point, you can see that your center is marked on the ground. So by using plumb bob you can mark your center, and you can make sure that that marking coincides with your instrument's marking. So this point is used for the centering. Then our instrument is provided with the 2 clamp screws. So for this base plate we are having the upper clamp and we are having the lower clamp screws. So these are now both screws are loose in condition. So by this one you can observe that instrument is freely moving. So this free movement of instrument will be happen whenever your low clamp is free. And once you tight this your low clamp screw, then now you can see that only the upper part of instrument is moving. So that is the basic difference. So whenever you have to take the reading, you make sure that your low clamp screw is tightened. For adjusting this lower clamp screw, we are having this lower clamp adjustment screw also. Now once I tight this upper clamp, then you can see that the instrument is not moving from its space. So the use of this upper clamp is for what? To fix the reading, to fix the instrument. So once you will lose this lower and upper clamp, then your instrument will be freely moving. Now use of these screws is for adjustment of two vertical scales or horizontal scales which are available with this instrument. So this instrument is provided with the two scales, one scale is vernier and one is the main scale, and also it is written there vernier A and vernier B. So on the both sides you can see that by using this mirror you can observe the readings which are available on that theodolite. So this mirror is provided again with the adjustment. You can adjust your eyesight and you can observe the reading. Then on the top of this theodolite portion you can see that vertical circle is provided. So this vertical circle is used for measurement of vertical angle. So whenever we are dealing with the vertical angle, we have to use this vertical scale for measurement of angle. For adjusting this vertical circle we are having this upper clamp. So once you lower this upper clamp, then your telescope will be moving from upward direction to the downward direction, and once I tighten this upper clamp, vertical clamp screw, then your theodolite is telescope is fixed in its position. For observing the readings for this vertical circle, we are having two verniers, that is vernier C and vernier D. So at the bottom we are having A and B, at the top you are having C and D. Now whenever you are taking the readings by using this theodolite for this repetition method, then you have to take the readings by using two different phase condition. So once when you take the reading, when this vertical circle is at your left hand side, then this position is called as the phase left condition. So whenever the vertical circle is available at the left side of the observers, then that condition is known as the phase left condition. And whenever you are taking the readings with this vertical circle on the right hand side of the observer, then this condition is known as the phase right condition. So in repetition method you have to take 3 readings by using phase left condition and 3 readings by using phase right condition. And when this telescope is inverted, now this telescope is in its original position, so this is the normal condition, and when you are taking the readings with phase right condition, then this will be your inverted telescope. This telescope is again provided with different screws. So this screw is known as the focusing screw. So this screw is used for focusing of our object. Then this eyepiece is provided with the 2 rings. So this ring is again used for observing the diaphragm to clear our vision, to clear the diaphragm. So this side is known as the eye side and this side is known as the object side. So you have to pass one imaginary line from this eye side towards this object side and you have to bisect your object. So these are some basic components which are used in the theodolite. Now this theodolite is having 20-second least count. So we have seen different components of the theodolite. Now we will see vernier scales of the theodolites which are used for measurement of readings. So now in the camera you can see that two scales are there. So one is the vernier scale and one is the main scale. So vernier scale is having the readings from 0, 5, 10, 15 and 20 which are seen to you, and the bottom scale, that is the main scale, is having the readings from 210 to 20, and these readings, in between these two readings you can see there are small lines which are present. So for example, if we take 20 to 5, so in this suppose 20 to 15, so in the 20 to 15 we are having 10 number of lines. So 5 big lines are there and 2 small lines are there. So one small line is giving us the reading of 20 seconds. So least count of this theodolite which we are going to use is 20 seconds. So whenever we will measure the reading, then we can measure the least reading up to 20 seconds. So when we have to take the reading, so you have to make sure that two lines which are coincides to each other, that will be our reading. So in this you can see that two scales are there. So this is vertical scale which is provided with the theodolite. So in this two verniers are there, vernier C and vernier D. So now you are looking at vernier D. So in this again we have markings from 0 to 20. So 0, 5, 10, 15 and 20. But in this vertical scale, what is the big difference? So vernier which is provided is having the markings on both sides. So instead of 0 you can see 20, instead of 5 you can see 15, and 10 is similar. And also the readings which are provided on the main scale
are varying from 0 to 90 degree, 0 to 180 degree. So, these are the markings which are provided on the vertical scale. So, when we are measuring the vertical angle, then we will use this vertical scales, and when we will measure the horizontal angles, then in that case we will use the horizontal scale. And you have to make sure that you must check the least count of the instrument before taking the readings. Now, when you have to observe the reading, then in that case you have to check that the two lines which are coinciding of the vernier and the main scale, that will be your angle only.
So in this practical we are going to measure the vertical angle of any point, so which is not accessible by us. So in this practical we are going to measure the height of that column which is available in the porch. So for measuring the height of that column, for measuring the vertical column, vertical angle between 2 points of that column from bottom to the top, we will use this theodolite. First of all I have set this instrument, centering is done, leveling is done. So bubble tube is at center, both bubble tubes are at center. So we will measure the reading of the vertical angle by with the help of these two vertical verniers, that is vernier C and vernier D. So simply I will loosen this vertical tangent screw and I will bisect the bottom point of that pillar. So this bottom point of the pillar is bisected by my telescope, and again after adjusting the line of sight I will tighten the lower clamp and upper clamp as well to restrict the movements of this theodolite. Now we will measure the reading which are present at this vernier columns, verniers. So we will measure this reading. So reading at vernier C and reading at vernier D will be recorded into our field book by taking the readings. After taking the readings, again you have to loosen this vertical tangent screw, you have to bisect the top side of this column, and then you have to tighten your vertical tangent screw. So now I will measure the readings again which are available at the readings at C and D verniers. So these are two main scales, and after taking the difference of these two readings we are getting the vertical angle of that column. So some things which you have to remember in this is that so the vertical angle will be different between the both readings, so starting reading and the end reading. So you have to take the difference of that two readings only. You can do this practical by using the face left condition as well as by using the face right condition. So by that way you can take a mean angle, and you can have the accuracy and errors will be eliminated. And while taking the readings, while writing the readings, you must be careful, because we have to take the readings in seconds also, because the least count of this theodolite is 20 seconds. So by note down the readings at both the verniers, vernier C and D, and by taking the difference between vernier C and D for both the readings, we have find the difference between both points. So the difference between both points, that is the vertical angle between these two points, is 51 degree 30 minutes and 20 seconds. So thank you.